SpaceX Starship Flight 9 is a focused engineering demonstration designed to validate key systems critical for long-term vehicle reliability, reusability, and operance. Begin with the core vehicle configuration. Flight 9 utilizes Super Heavy 14 and Starship 35. This will be the first time a Super Heavy booster is reflown, and of the 33 Raptor engines installed on the booster, 29 are flight proven from previous missions. Several of these engines are embarking on their third operational cycle. Now, the explicit engineering goal here is to validate the durability and the performance of Raptor engines through repeated launch, shutdown, refurbishment, and relaunch. Now, the data gathered on engine wear, refurbishment time, and post-flight inspection will directly inform maintenance protocols and long-term cost models for fleet operations for SpaceX. Now, on the propulsion side, Booster 14's engine gimbal systems have been further refined for this flight to reduce vibrational coupling and resonance during throttle transitions. The booster's plumbing and propellant feed systems have been re-engineered to address combustion instability and also pressure fluctuation issues which were observed in prior flights. Now, SpaceX is specifically monitoring for transient pressure spikes, cavitation, and flow separation events, all of which have the potential to cascade into engine out scenarios if not properly mitigated. Let's move up to the upper stage, Ship 35, which incorporates a suite of structural and thermal protection upgrades. The heat shield now uses a revised tile mounting system with improved gap fillers. This is a direct response to the uneven heat loads and tile detachment incidents we saw in earlier flights. The new system is designed to accommodate differential thermal expansion and dynamic pressure loads during ascent and also during reentry. They also reinforced the aft fuselage and repositioned the aerodynamic control surfaces of the ship. Now, the flaps are smaller, thinner, and mounted closer to the nose, which should provide improved control authority during descent and also reduce thermal exposure to critical surfaces. Now, a major focus for this flight is avionics. For the first time, Starship is flying with a triply redundant flight computer system. This architecture means 3 different computers process all critical flight inputs in parallel, allowing for real-time cross-checks and system reconfiguration in the event of a single-point failure. The flight software stack has been rewritten to leverage this redundancy, incorporating hardened protocols for error detection, isolation, and recovery. And they're aiming to demonstrate that a single hardware or software fault will not propagate through the system or compromise mission safety at all. This is foundational for future crewed missions and for meeting regulatory requirements for human spaceflight. The telemetry and sensor networks have also been overhauled. They are now collecting high frequency, high integrity data from structural joints, pressure critical interfaces, and all major avionics nodes. The communication stacks has been rebuilt with more resilient hardware and software, with the explicit goal of eliminating data dropouts and ensuring complete mission data capture from launch through recovery. Now, this will give us a much higher resolution view of vehicle performance, particularly during dynamic events such as stage separation and also reentry. Propellant management in Ship 35 has been upgraded with larger main tanks, now sub-tank systems, and internal baffles, and the feed lines have been reoriented to counteract sloshing and also bubble formation, which are known to compromise engine restart reliability and thrust balance during coast and relight phases. SpaceX engineers are continuing to use autogenous pressurization, cycling gaseous methane and oxygen from the main tanks back into the system to maintain tank pressure and reduce reliance on high-pressure helium or nitrogen. And stage separation is another area where they've implemented changes. The mechanism now uses altered bolt placement, stronger structural interfaces, and a modified pusher plate. Now, the intent is to produce a cleaner, more reliable disengagement between the booster and the upper stage. This reduces the risk of collision and damage and ensures proper timing for upper stage ignition and also booster return trajectory. The flight plan for Flight 9 is designed to isolate and evaluate these upgrades under operational conditions. The booster will not attempt the tower catch. Instead, it'll perform a controlled splashdown in the Gulf of Mexico. This allows SpaceX to focus on in-flight vehicle behavior and landing stability without introducing the additional variables of ground-based recovery. Ship 35 will also perform a controlled descent and splashdown, with data collection focused on validating the performance of the upgraded heat shield, the structural reinforcements, and avionic systems through re-entry. On the ground, Starbase's infrastructure has been upgraded to support the new vehicles as well. The water deluge system under the launch pad has been expanded to absorb the increased thermal and also acoustic loads from 33 Raptor engines firing simultaneously. Now, the tank farm now features improved cryogenic storage and transfer systems to support rapid vehicle turnaround and minimize the propellant boil off for these flights. From an engineering perspective, the objectives for Flight 9 are to validate the durability of reused Raptor engines, demonstrate the reliability of the new triply redundant avionics and also flight software. Now, they're also going to assess the performance of the upgraded heat shield and aerodynamic surfaces, test the new propellant management systems, and evaluate the redesigned stage separation mechanism. Every piece of flight data will be used to refine the vehicle design, inform future hardware iterations, and support the case for operational and eventually crewed missions. So let me know down in the comments what you think about Starship's Flight 9. Do you think they're going to be successful in landing the booster in the Gulf of Mexico? Or do you think there's going to be some sort of incident with the upper stage like there has been in the past? Let me know in the comments down below. And also, while you're down there, hit the thumbs up button, helps with engagement, and also subscribe to the show. You'll get more Starship content like this, not just from me, but from other Starship creators on YouTube. Thanks so much, everybody. Take care of yourselves and each other, and I'll see you in the next one.